Our first speaker for today is going to be Ilian Iliev. He's been programming since 2003, and he's currently working as a software engineer in Lifesum, based in Sweden. Today, he's going to share his insights and lessons learned because we all have made mistakes in the past. From tiny bugs to crushing production for hours, just yesterday. So, big round of applause, please. Spam in chat for Ilian.
Thank you, Rado. Hello, I'm Ilian. I've been programming for quite a long time, and during my career, I have made quite a few mistakes, and I have crashed production. And now I'll tell you about how it happened and what I learned from this and how to avoid this happening for you. So let's start with one of my first tasks as a professional developer. We had a system, and that system kept some stages. Each stage had a certain percent, and the users were supposed to make payments based on those percentages. And at some point, one of the product owners decided that, we only have integer as percentage here. So instead of that, we want to have float because we want to do 2.5% stages and stuff like that. So I said, it's not a problem. Our system is dynamic in that case. So we just need to modify the table to store the correct values. So yeah. I wrote the simple outer table statement, run it on dev, it worked perfectly, run it on production, it worked run it on test environment, it worked perfectly, everything looked great. And then, when I decided to run it on prod, I decided that I want to optimize. And I said, why should I have float 16.2 when I can use float 3.2? With the idea that 3 will be the integer part and 2 will be after the decimal stop. Unfortunately, I found out that I have a bad understanding about what float 3.2 means. So what happened is the following. Everything that was equal to 10 or greater got rounded down to 9.99. So what the command says is that the first digit you provide is the total number of digits that you used, and the second digit is the number of digits after the decimal sign. So yeah, practically thousands of records messed up on production. Our system administrator at that time, he was working on a different time shift, so I had to wake him up, wait for a few hours for him to bring out a backup and to restore the data. And meanwhile, the client was calling and asking, when is this going to be ready? So yeah, it was quite scary. What I learned, never do changes between test and production environment. That's really important. Another issue that I had here is that I wasn't fully understanding the command that I was running. But the most important thing is, if you try something, release the exact same thing that you tried. Don't make changes without testing them and just deploying to production. Let's see another one. Updating data on production, that's a bit more recent one. So we had a system, we're handling some users' data, and also we used third-party accounting system that was requiring consecutive customer IDs. At some point in time, another developer decided that they need to test something with the accounting system, and in order not to mess with the accounting logic, they just changed the next ID to ensure that the next customer ID will be created with a far greater number, and it can always be removed and cleaned up after the test is done. The problem is that the sequence was never reset after the test was finished. So at the end of the month, we had hundreds of customers with invalid IDs. And because this is accounting, there's no way to easily, you can't say, I just start from this point on. No, you actually need to roll back everything. So I wrote an update script, and it was super simple. We start from a certain sequence number. We take all the customers that has an ID greater than 1 million, which was the test value. And for each customer, we change the customer ID according to that sequence number, increment the sequence number, and then just save it. And that was fine. It was going to work fine if I didn't do this. It's just a small typo, but I messed the sign. The result was that instead of updating the invalid data, I updated all the valid data. And the accounting system says that once a customer has an ID assigned, it should never be changed. So we had to restore. The lesson learned here: never run untested code on production. It was such a simple change, and because the data was modified only on production, I decided that, okay, I'll write it, it looks good, I'll run it. So don't run untested code on production, and always have someone with you to take a second look when you're making those changes. Another lesson learned: replica is not a backup. You see, our database has a replica server in case the master falls down or there's some other issue. And replica was working fine. We have seen it before when the server was crashing or something like that. The problem was that replica is not a backup because all the data I updated was replicated immediately, so I had no way to restore it. And we didn't have backup. So we managed to solve this by looking into the binary logs and doing some special digging, but it was really hard. I worked the whole night to clean it up, so it was a bit scary. Another problem that we had in the same company, actually, we have a newsletter software as a service system, and we sent around 1 million emails per day. And then the mail server died without notice outside of office hours. You need monitoring and alerts. The problem was that we never noticed that the server was down. And the server was down for a few days. There was a weekend. There was a high demand because it was the days before Christmas. People were completing everything. The mail server is hidden from them, so they never saw an error or anything. We didn't have monitoring at that time. So as a result, it was just that clients were quite angry, and it was a big loss for both our clients and for the company reputation. It was solved after a few days, but yeah, immediately after that, we set up monitoring, keeping us informed if there's a problem with a certain service, and not only monitoring, but immediate alerts to make sure that nothing will be missed. So, on my first job, it was 2003, I was talking with some colleagues, and I asked them, okay, why do we use integer 10 in MySQL databases? And they explained, okay, that means that we're using 32 bit integers, and they have certain limitations. So I asked, okay, what if you run out of IDs? And they all laughed. They all laughed at me and said, oh, you never run out of IDs. That's like, if you have signed, you have 2 billion IDs. If you have unsigned, you have, if you have, no, never mind. Anyway, you never run out of IDs. Several years later, I called one of my colleagues from that company. I was working on a different place there, and asked, okay, do you remember what happened when I asked what if we run out of IDs? And he's like, yeah, I remember it. We keep telling this joke to new colleagues. They're all laughing at you. And I'm like, okay, we're actually running out of IDs. We have a table that's running out of IDs, and at the moment when you finish and you try to put a bigger number, it will just round it to max int, and if it's a primary key, it will fail. So we set a doomsday calendar. We had it on our wall. we're looking at it, we're discussing different solutions. We talked about how to solve it, and everything looked good. We made a plan, and we executed it. And then, a few years later, another table ran out of ideas. But this time, we had no calendar. We just missed it. It happened in the middle of the night, and it just crashed. Everything, like clients were having tons of problems, and it was really going bad. We had an on-call team that is responsible for handling those issues outside of work hours, so they jumped on it immediately. They made all the changes that was needed on the platform side. They restored the backup, and a few hours later, and a sleepless night, everything was running back normally. The problem was that the hotfix was not synced with our mobile teams, so they kept using the 32-bit integers while we were already switching to 64. As a result, they had some weird behavior on the app. Numbers were rounded, numbers were just messed up. It led to a bit of a data loss, but it was solved at the end. What I learned is that if something is going to happen in several months, then set a team reminder. People come to the company and then leave. We change office during that time. So there are a lot of things that practically made us lose the knowledge and erase from our memory that, oh, this problem is going to happen again. We have other tables that are candidates for that issue. Another lesson learned, always communicate major changes with all teams. Because it was such a late during the night fix, everyone is tired at the morning, everybody is thinking, okay, everything is fixed now, I just want to go catch up with a few hours of sleep, and so on. Nobody actually thought, like, they sent an incident report, explained that everything is working now, everything seems good, the servers are back and running, the system is online, went to sleep. We read the incident report in the morning, everything looked good, and nobody thought about the mobile teams. So always communicate this with all teams and speak about what are the consequences with them. Another issue we had, we had a system that users can upload a bunch of images, and it was slow. Because we're doing some processing, resizing, storing them in a different places, sending confirmation back to the client, and this was slow. It was significantly slow that the users were actually complaining from it. So we thought, okay, maybe there's a way to improve the speed. So the user sends the image. We don't need to process it synchronously. We can just put it somewhere else and start processing it later, and once it's ready, we'll send confirmation to the users. So what happens is we added the queue. We said, okay, this queue will be consumed by a worker. The worker will process the images, will put it in the storage, and the API will just send a confirmation to the client that, yes, your image is uploaded. You'll get all the details later. That looked like a really smart idea and a good way to actually to move the delay from the customer to actually our system. The problem was that the same queue service was used by multiple tasks. And on top of that, it was a machine running with 512 megabytes of RAM. And we have millions of users. So practically what happened is that an hour after this was deployed, the servers overloaded because all those images were kept in the memory. The queue was full, other things stopped it, the queue filled up, the server crashed. Fortunately, that was what was going to happen. We catch this during review. But the lesson here, the lesson is consider the resources usage. When you're going to rely on some other service, when you're doing calculations that use a lot of CPU, or when you're using larger objects like images or files, always consider the resources usage and where exactly those resources will be allocated. Is it possible that they will lead to some crash of the system? Is it possible that maybe you can still do the processing later, but maybe store the files or store the data immediately somewhere without actually putting load on a queue? Another thing to consider here is that we're using the same queue for a lot of different scenarios, and that could lead to a problem that one issue, like a slow image processor, can block a lot of other tasks that are related to user purchases or data returning data back to the users. So let's speak a bit about using third-party APIs. The context here is that we use a third-party service providing currency exchange rates because the service is not reliable every now and then. I mean, it's a network connection. Every time when you communicate over the network, you need to think about, okay, what happens if it's down? Maybe the other service is having problems. Maybe there is a network delay. Maybe something has happened. So we have the rates cached. We try to renew them after a certain interval. If the renewing fails, we use the default for a certain interval. And if the renewing failed for a long period of time, we actually switch to a zero value. That was good. In general, it was working pretty well for several years. Nobody complained. Everybody was happy. Our accounting department was happy with the results. Our customers were able to purchase products from us. Everything was fine. The problem was that at some point our authorization key was invalidated and the service started rejecting calls. So no errors were reported. And no errors were reported because we always thought that, oh, this will be a network failure. It might be down for a moment, but it will be back up maybe like 5 minutes later. Or even if it's 1 hour later, that's not a problem. But here, we're talking about the service rejecting us for weeks without us noticing. That was problematic. And it was actually discovered by one of our data analysts. And they say, oh, you see, I see a lot of weird values in the financial report. Why is this happening? So we started digging, and we saw a lot of payments with exchange rate being zero. And I'm like, okay, that's really weird. What's happening? We started looking at the code. Nothing there was changed for a really long time, and it used to work, so everything seems fine. And then we started debugging it piece by piece and piece by piece, and at the end, we figured out that the problem was this faulty service. So the lesson learned, always log your errors. Especially when you were talking about third-party services. Things can go really wrong there. It's possible that they are going into maintenance mode, or maybe they're even going out of business, but they used to communicate with the person on the team that is no longer with the company. So nobody ever received notice about changes or about the service shutting down. And because it's running smooth, everybody thinks that, oh, it's fine. It just goes. There's nothing to be touched there. So always log your errors. So another scenario, we have a monolith. It's a really old system, maybe 8 to 9 years old. At some point, we started taking pieces of it outside and creating multiple microservices to reduce the load, to improve the scaling, to actually make it easier. And also because the monolith is so hard, it brings a lot of burden to maintain. Like every version update is a trouble. We made an update from Python 2 to Python 3, which took several weeks to cover all the code. We had some troubles during release. So yeah, we want to chunk pieces apart, and we started writing microservices. And microservices uh, we have different things. We created a microservice to handle the user settings. And it was going good. We also had some, we had cache for lots of other stuff. But when we migrated to the microservice, we said, oh, we don't want to cache the settings anymore. This will be, the microservice will be super fast. There's no need to cache, everything will be smooth. After we released it, what happened is that everything worked, it was fine. And then at some point, a colleague said, oh, I want to change another service. We're using Redis in a bit of a weird way. We put keys there, we never expire them, let's start expiring. Everything was tested, everything was fine, everything worked good. And when we released this minor cache change, everything crashed. Like the monolith crashed, all the other systems started crashing because they depend on the monolith and vice versa. It just, everything was red. For a few hours, we rolled back, we reverted the changes, we deployed again. The problem was still there. We thought, okay, maybe the cache is going crazy. We cleaned the cache, like a few hours of chaos, and at the end, everything was fine. And well, okay, let's examine this. Let's see what happened. What happened was that everything was good. We deployed again, and it happened again, even that we made some minor tweaks. And we couldn't figure out what was going on until a few days later, we faced the same issue without actually deploying the new changes, running the old system and having the same issue. So we said, okay, let's see what we will do. Let's try to dig up and check the logs. What happened is that we have irregular traffic during the day. We have moments that have really high traffic and really low traffic at different parts of the day. And the deploys that we first tried, they were actually coincide with the traffic peaks. And it was actually another microservice that was responsible for the crashes. But because the problem coincided with the deployment, we thought, oh, it's the deployment, let's roll back. And when we roll back and it didn't work out immediately, we thought that, oh, it was still caching or something like that, or like services are overloaded, instead of actually looking at, okay, maybe that's not the reason. So what we learned, read your errors carefully. The problem in those cases is that first you're stressed, like everything is on fire, the system is down, it's not working, clients are calling and complaining. You want to solve it as quick as possible, you make your changes, it's not working immediately, you get even more stressed, the whole team gathers, everybody has ideas, but at the end, after a few changes that you think are solving it, everything is back to normal and you say, okay, yeah, that was the problem. We solved it. And during that period, we gathered so many errors in the log that it's hard to actually figure out which were valid and related to the problems and which are side effects of, oh yeah, that service died and for that reason it started throwing errors. So when we actually saw that the problem happens without us deploying, we realized that something is wrong. So we started looking again at the error logs, and we found out that yes, another service was crashing. It was a service that was badly configured to scale. So as a result, during moments of high load, it was crashing and it was pulling everything down with it. Another lesson learned here is that you should always set timeouts for network calls. The problem is that when you communicate over the network, you never know what will happen. You never know if the other service will be up. You never know at what capacity it will be. You never know if the network is fine, if it's fast enough, or maybe there are some delays. Maybe there's something happening at the data center that is changing it. And if you don't have timeouts on network calls, it's possible that that your main service that is calling your other service, it will just wait. It will open the connection, make the request, and it will wait. And because the subservice has reached its capacity, it will just start like putting requests in the queue. And then your main service, it's like, okay, I've opened this connection. I can't respond to the users that made the request immediately because I'm waiting for the data. And then another request comes from another user that wants the same thing. And it happens again. Okay, I'll also wait here, I'll wait here, I'll wait here, I'll wait here. And a few minutes later, the capacity of your monolith is full. It can't accept any more connections, and it starts crashing. Or it starts scaling up to handle the load from all the users and put more and more pressure on the service that is the actual problem. So please put timeouts for network calls. This is going to save you a lot of time and a lot of problems. Another lesson here, time your deploys. As I said, our traffic varies quite during the day. We actually have our company, it's in the health industry, and our traffic is not regular. We have a really high January, we're talking about 20, 30 times higher than the usual traffic. And then during the week days, we have lower traffic on Fridays and Saturdays. We have higher traffic on the mornings on Monday and Tuesday. Then it goes a bit down. During lunchtime, it increases again, and so on. And everybody at the company knows these things. But for some reason, we decided that, oh, maybe it's safe to actually do a deploy now. It shouldn't, like, we have a system that will auto-scale. It's not a problem. It should. We have done it before. It's not the moment of the super high peak. It will be fine. We deployed, it crashed. So yeah, time your deploys. Think about what load you have at the moment. Think about the load that is coming, because if you do a deploy right before the increase of the traffic and something goes wrong with the deploy, you need to have time to roll back. You need to have time to revert. So be careful. In some systems, that's not really possible. Or you have to do deploys outside office hours. And yeah, this is understandable. Try to avoid that. Try to find a spot during office hours. Try to find a spot that is in your working part of the day, that is not right before you go home. Don't do deploys that you just, I deployed that, I think it should be okay, I'll grab my stuff and leave the office, because this can go terribly wrong. Okay, let's see some changes that does not have a real effect. We have a Django app. Django is a pretty good Python framework for building web apps. It's been around for several years. It's really durable. It's well supported. It's evolving gradually. It's awesome. But it has some bugs or quirks that you need to be aware of. So we did a minor model change. So our model is the code representation of our database tables. And we add a small change named blank equals true, which practically says, oh, when I use this model in forms, the value can be empty. But this change, it does not have an effect on the database. It doesn't change the way it doesn't change the table structure. What it changes is just when you use this model in specific forms, it just brings or like removes some validation errors. It's practically just user-facing. It's nothing that should affect the database. And a new migration was generated, which was a bit weird. But when we look at the migration code, we saw that the only change that is happening is the addition of this blank true. And also Django generates such changes when you change the options or like help text to those models. So that shouldn't be a problem. All the automated tests were green. We deployed that to test. Everything was fine. So we said, okay, yeah, maybe we can deploy to production. Deployment on production caused a database crash. So what happened is that we had a really long running query locking the table slowing down the whole server, and eventually everything crashed. Like our monolith, our services, some of them used the same database. The database was fully loaded. They couldn't do anything, so they just started like falling down one after another. We wrote back, stopped the weird query that was running and taking so much time. We started investigating, and we found out that the migration unnecessarily dropped and recreated the foreign key. It's a known bug in Django, but we found that later during our investigation process. So actually, what happens is that even changes that don't affect the database result in the table dropping the foreign key and recreating it. And that would have been normal, and it worked fine on our test servers where we have less data, where we have smaller load. But on production, we're talking about tables with millions of records. And running an index change on such a big table can take quite a lot of time. It practically takes minutes. And I'm talking about like 10 to 15 minutes thing. So we found out later we figure out how to ignore it. We marked the migration like it's executed. We deployed, everything was fine, everything was working, but we still had downtime. And downtime is not fun. So, what we learn? Always check migrations SQL. That's when you have automated tools that interact with your database. When you have automated tools that make changes on the schema or that execute queries on your behalf, always check the pure SQL that they will generate, because even small changes that are not supposed to affect you in any way, they can bring you down. So just checking it is a simple task. Just check it, verify it, consider it. Maybe use an explain to see what exactly will happen if you're not sure. But take a look and verify what you're doing. Okay, final words. Don't panic. That's literally the worst thing that you can do. No matter what happens, don't panic. There are industries that are a bit more severe in the terms of like, going down for several minutes can cause a lot of troubles. It can be money loss, it can be reputation loss. In some industries, bugs can even maybe cause the cost of human lives. So be careful. When things go wrong, don't panic. When you panic, you start making more mistakes. You stop thinking. Always evaluate good what you see. Okay, do we have those errors? Yes. Are they related to what we're seeing? Yes or no? Is there a reason why this could be failing? Is there another reason that maybe that wasn't the cause for the crash? Don't panic. Take a deep breath. Think about it. And then just solve it. That's it from me. Thank you all for watching. And if you have any questions or anything, I'll be happy to help you.
All right. Thank you very much. We actually have questions.
Oh, good.
But first, we can imagine a big round of applause from everyone. They actually spam in chat, and it's really good. So
awesome.
you had spam in chat for your talk, which was good. And there are questions, and I'm going to ask you, and then you can answer. Oh, thank you. I was out of the screen.
Yeah, you see, it happens. When it's live, things happen. Just don't worry.
Yep. So good. So the first question that I got is, isn't it a golden rule to deploy in non-production hours? Asked by Alex.
It depends. Deploying. I remember some years ago we had to change the database service. We had everything self-hosted. We had to change disks on the database server, so we practically had to turn off the whole system. We're expecting 1 to 2 hours of daytime. We synced that with our guys at the data center. They were going to do the change. We synced everything. And yes, in that case, it's normal. We said, okay, we'll finish a bit earlier today. We'll come back to the office midnight and we'll start doing the changes. It was actually a client who called and said, oh, your system is down. What's going on? It was like 2 a.m. or something like that. So it was a bit weird, but Yeah, we explained everything was fine. Customers are actually understanding, especially if you give them some information in advance that will have maintenance window. But those are exceptions. You can't expect from your employees and your colleagues to come with you together to spend the night of the office to do deploys. And also the problem is that if you say, okay, we'll do deploy after or outside work hours, you can't expect everybody to be there. So instead of a team of 10 people, you have maybe 2. So if something goes wrong, you have less people to fight it. You have less knowledge. So it's, I would say, try to find a good spot during work time.
Yep, and I think you mentioned something that's very crucial, and we as end users are used to it, and that's maintenance windows.
Yes.
And if you say system is going to be in maintenance for the next 15 minutes to hour, I think everyone's expecting it. Most of the big apps are doing it. So yeah. The second question is a bit more philosophical, I suppose. Are we destined to repeat our mistakes?
Oh, that's
and how do you distribute this kind of knowledge that you've acquired to a place that has not yet acquired this knowledge?
Well, let's talk about how to distribute the knowledge first. This conference is an example of how to distribute the knowledge, how to share this experience and say, okay, this is what we did wrong. We'll try to remember it and not do it again. If I'm going to say that I'll never crash production again, this is just not true, because things happen. Sometimes hardware fail. We had a hardware failure just right at the beginning of the conference. So
we slapped laptops. It was supposed to be a different machine, like 5 minutes before we start.
Yeah, so things will fail. Sometimes it will be your fault. Sometimes it won't be your fault. But try to think it. I remember when I was starting my current job, we were discussing with my new boss what's expected of the work. We're discussing what we have done in the past, how stable they are, and so on. And he said, it's okay to make mistakes because you're trying to move forward. It's not okay to make mistakes because you're sloppy.
Yeah.
Because just be careful. Think about it, think twice. Try to have another person to always take a look at your code.
This is very well said. Yeah. Make mistakes because you're trying to move forward, not because you're slow.
Yes, I mean, we saw Facebook going down for how long was it?
Like 12. I'm not sure if it's 12 hours, but for us it was like during the night period.
Yeah, and I mean, these are companies that they have a lot of people there. They have, I'm sure they have more security checks on things before they go to production than our company, for example. But you see, things happen, so.
Yep, of course. It was really funny that they ended up using an angle grinder to to open up the door. But there's one more question: Monday versus Friday deployment? Question mark. This is I'm reading it.
Okay, don't deploy on Friday. That's the short answer. Don't deploy on Friday. So for us, it's a bit different. For us, Friday is one of those days with low load, so it's more safe to do deploys. The problem with Friday is that everybody is already thinking of the weekend. Sometimes you have people that work maybe 4 days a week, so Friday is off for them. In our company, we also have, we take these on-call weeks, and after on-call weeks, you take a day off next Friday. So Friday can be a bit tricky. And also, if something happens, you have less time to react. And by less time to react, I mean that even if you roll back your changes, you get everything fixed in like, I don't know, 15, 20 minutes, the system is back operational. If you have messed up the data in the database, that may require a lot of cleanup, and you don't want to ask people to do it during the weekend.
If you mess
no,
up
it's not fun.
Yeah, for sure. I completely agree with you. Don't deploy on Fridays unless this is like the lowest possible traffic day for your client.
Yeah, and always do a smoke test after deploy, because we've had colleagues like that. Oh, I deployed the time leaving. Have you checked it? It's running. Fortunately, it's running usually like 99% of the time, but check it out.
Right, and we have one more question, which is again a bit on the philosophical side. So it's related to the first one. If you don't expose teams to such critical scenarios, how can they learn?
Oh, As I said, those scenarios will happen. I mean, teams will face it at one point or another. And I mean, you can maybe try to simulate something if you want to do some internal training of how to handle it. But I think it's a matter more like, for more experienced people, they try to panic less. As I said, they try to be more calm and more focused. For juniors, it's a bit more scary. But something really important is that once something happens, once everything is calm, once you put all the fires down, do a post-mortem.
All right.
Speak about what has happened. Speak about what were the causes. Write it down and keep it in your whatever you use for documentation.
Right, yeah.
You can always ask people who are joining the company to, just read one of those documents and remind it to the company because there are other people joining. I think this is a good way to learn.
Yeah,
and be kind of prepared.
Yeah, very good idea. Read what happened because it will most probably something like this will happen again.
Yeah, I mean it's normal. We're people. We make mistakes, but
I think that's about it with the questions. Thank you very much.
Thank you very much.
It was really nice talk. A lot of insightful things to say. Today is Friday.
I'm not deploying today.
So
Definitely
I'm
not.
also not deploying today, so it leaves you should not deploy today too. Thank you very much. We will be back at 3 p.m. exactly with the next talk. Until then, you can check the other stages.
Thank you and hope to see you again.